Hello everyone, today we're going to be working on set operations and how to understand the Venn diagram. Now let's say we have set U, which is our union set, and it's composed of A, B, C, and 4, 5, 6. So we can draw a diagram enclosed inside a rectangle like this, and this will be our union set. Now let's say we have a subset of U, which is called set A, and in our set A we have the elements A, C, and 6, which is ultimately a subset of the union set or set U. So we can have A is a subset of U. And if we're going to modify our diagram and highlight our subset A, we could have a diagram like so, which shows you the subset A containing A, C, and 6, and the rest of the elements that's not found in A, which is also in the union set, will be outside the circle, which is your group A. And this is what we call as the Venn diagram, wherein we're representing the subset of the union set inside a closed circle. So this is the representation of set U, wherein A is a subset of U. Now there are several ways on how we can show a Venn diagram. We have the disjoint sets and we have the proper subsets. Now in the disjoint sets, as you will notice, there are two groups, which is set A and set B, and there are no elements in set A that is common to set B if the set is supposed to be disjoint sets. And when we have the proper subsets, in this particular case, all the elements of set A, which is inside the set B, will be enclosed in the union set. So this one is a proper subset, and these are some of the subsets that we're going to be using in our subset operation. Now let's say we have a Venn diagram represented by this particular diagram over here. The union set U will compose of all the elements of A and B and the elements that's not in A and B. So if you will notice, we have groups A with 1 and 2, and groups B with 2 and 3, and the outside group, which is group 4, has an element of F and G. So this is our Venn diagram, and if we're going to identify some of the subset here in our Venn diagram, let's start with set U, or the union set. That means we're looking for all the elements in set U, and in this case it will be A, B, C, D, E, and F, G. So it's all the elements inside your union set will be included as your set U. And if we're just going to be working on set B, that means in set B, you will see that group 2 and group 3 are still inside set B. So that means in set B, we have the elements letter D and letter E. And if we're going to determine the set of elements in the union set, but not found inside set B or subset B, that means we're only looking at A, B, C, and the outside elements, which is F and G. So our third group of elements, which is the elements in U but not in B, would be A, B, C, F, and G. So this is how we look into the Venn diagram and identify some distinct elements in a specific subset. Now let's talk about complement of a set. Now complement of a set, which is given by this symbol A apostrophe, or sometimes we call it as A prime or A complement or complement of A, is basically X, such that X is any element in the union set and X is not an element of set A. So to understand this better, let's have an example. Let's say our union set U is or has an elements of 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we have set A, which is a subset of U, which is 1, 3, 4, and 7. If we're going to find the complement of A, that means we're finding all the values that you cannot find in subset A, which is going to be 2, 5, 6, 8, and 9. So these are the numbers that's not found in A, but it's found in the union set. And in set notation, we call this the complement of A. And if we're going to show a diagram representing the complement of A in a Venn diagram, we can have a union set wherein the subset A contains 1, 3, 4, 7, and the complement is usually outside the group of your subset, which is in this case is A. So you will see 2, 5, 6, 8, and 9 in your outside circle, but still in the union set. So this is how we represent the complement of a set or subset given a Venn diagram, and of course by just working on the operation. Now if we have a complement of a set, another operation in subset or set notation that we're going to be working on will be the A intersection B, denoted by this symbol. So in A intersection B, also known as A and B, or the AND operation, X is an element of A and X is also an element of B, and if both distinct elements are found in both subset A and subset B, then A is intersecting B. So the intersection of set A and B is the set of elements common to both subset A and subset B in a given union set. So let's say we have two sets, set A and set B, which is in set A we have 7, 8, 9, 10, and 11, and set B we have 6, 8, 10, and 12. If we're going to find the intersection of A and B, it will be the distinct element that you can find in set A and also in set B, and in this case they are 8 and 10. So the two numbers that you're seeing would be the intersection of the elements in set A and B. And if we're going to draw a Venn diagram that will represent A intersection B, we'll have a Venn diagram with two groups, which is A and B, and in this group we will be seeing an intersecting circle, and in that intersection lies 8 and 10. So that's why if we are looking for the intersection of a set, it is basically elements in set A that can also be found in the elements of set B. And in this case, 8 and 10 is the intersection of A and B, or A intersection B. So if we have an intersection of sets given by the downward U, we also have the union of sets given by this symbol, which looks like a letter U. Now the union of sets given by this symbol is basically the union of sets A and B, that is the sets of elements that are a member of set A or of set B, or both sets. So basically we're finding all the elements that's common between A and B, and also the elements that's not common in A and B. So if we're going to have set A, which is 7, 8, 9, 10, 11, and we have set B, which is set 6, 8, 10, and 12. If we're going to find A union B, also known as the OR operation in some cases, we'll have 6, 7, 8, 9, 10, 11, and 12 as the set of A union B, because in this particular union, all the values that you can find in set A and set B would be included in A union B. So this is basically how we're going to write the distinct elements of both sets. And since you are seeing 8, 10 on set A and 8, 10 in set B, you'll also see that in the union set of A union B, because you're basically just writing all the elements that you can find in A and B, and there's no repetitions or doubles that will be included in your subset. So this is how we're going to write our diagram or Venn diagram in A union B, wherein you're using all the elements that you're seeing that is exclusive to A, exclusive to B, and union or intersecting A and B. So these are some of the operations that we're going to be using in subset operation or set operation. We'll see the complement, we'll see the intersection, and we'll see the union of sets in some U or set U. So let's say we have a set U or union set of 1 through 10, and we have two subsets subset A, which is 1, 3, 7, 9, and subset B, which is 3, 7, 8, and 10. If we're going to find the two distinct groups of subsets for letter A and letter B, which is for letter A, the complement of A union B, and for letter B, the intersection of complement of A and complement of B. So let's work with the first statement. We're going to find the complement of A union B. And just like the order of operation, we will treat it as such. So we're going to go from the inside going outside. So we're just going to be focusing on all the elements of A union B. And if we're going to find the elements of A union B, it will be all the elements that's distinct from A and B, and they are 1, 3, 7, 9, and 8 and 10. So that will be the union of A and B. However, we're looking for the complement of A union B. So going back to the union set, which is 1 through 10, we're just going to include all the numbers that's not found inside A union B. So that means the complement of A union B would be any number except on the first set of operation, and they are 2, 4, 5, and 6. So the complement of A union B is going to be 2, 4, 5, and 6. So this is an example on how we perform set operations involving a union set. Now let's work on the second subset, which is A complement intersection of the B complement. So we're going to find the intersection of A complement and B complement. So what we're going to do is to list down all the elements of the complement of A from the union set. So we know that A is 1, 3, 7, 9. So if we're going to find the complement of A, it would be 2, 4, 5, 6, 8, and 10. So that will be our complement of A. And if we're going to find the complement of B, it will be the numbers that's not found in B. So therefore, we're going to find or get 1, 2, 4, 5, 6, and 9 as the B complement or B prime. And since we're looking for the intersection of A complement and B complement, we're going to list down all the numbers that's distinct to A prime and distinct to B prime and put it in one single set, which is A complement intersection B. So in this case, we're going to get 2, 4, 5, and 6, which is common to A complement and B complement, and that's basically the intersection of A complement and B complement. So this is how we use the operations involving subsets in the Venn diagram.